Hello. 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 How are you doing? I'm doing great too, thank you. You voted for me to be MVP on top corner. Okay, thank you. Um, should I vote for someone too? Can you give the link? So, today as usual we are gonna do Snark News series, winter series, round 3. This is the third stream, so it's the third round, coincidentally. And yeah, change the title. Sure, thank you. Change the title. Okay. 12 years, nice. So, can I show in a few minutes how to copy codes with true template? Well, the thing is, I was like, yeah, a friend of mine showed me once how to use it, and actually it's been a while, so maybe I should have another stream which explains that, but in general it doesn't matter too much. I mean, you might use it, you might try to use it to set it up, or you might use some kind of live templates of other IDs, but I mean, if you just go to your folder with codes and just copy the code of some algorithm you want, then it will still take you like, I don't know, 20 seconds. It's not too much. I mean, in general, I don't think that you're gonna lose too much or just perform too badly in this case. So just I think you just should not be too worried about the setup or like using the correct IDE, because it just doesn't matter too much. Whatever you feel comfortable with, you just use it and it should do. It should do. Just don't worry. You want to participate in Top Core, but you can't find C++ competition? What you mean? I mean, obviously, you can use C++ at Top Core. What editor have I used at IOI? So, for the first, yeah, I think it changed. So, I mean, it is a Linux only competition, right? At least for a long time. I guess it was so even the first time I went there. So I used Kate initially, and then I used Genie, I think. And I mean, it was fine. It's like I used Genie at Google Code Jam as well. So, I mean, just whatever, wherever you just can type, whatever thing you can use, it just doesn't matter. Why do I use iOS-based sync with stdio false cyan.ty null? So this is well, kind of magic words that, well, turn off synchronization of like IO stream with stdio, and this way IO stream works faster, like C in, C out, and CI tie now also helps that. And basically in the newest versions of C++, using C in with and these two lines makes it pretty much of the same speed with scanf. So I used to use scanf for reading, but now I use cin. Is it allowed to use my library? I guess for the time being I don't have any rights, like license. So I guess whatever you find you can use. Are you planning to stream Code Forces contest stream? Well, so I'm not planning to stream Code Forces live rounds as they go, but I could, like, maybe I could stream just a contest after it ends. But this way it's not like a competition, right? It's more like upsolving, and I'm not sure it will be as exciting for me and for you as doing live competitions, but we'll see. We'll see. We'll consider that. Is the sound good, by the way? I guess. No one told me that the sound is bad, right? So should be good. Nice to see you in a new contest. Yeah, nice to see all of you watching too. Do I plan to do some educational videos soon? Not yet. What do you think about these streams? Are they educational enough? I don't know. I mean, if you mean just educational in the sense like cover some topic or I don't know, solve problems about some, I don't know, problems about strings, problems about graphs, or just describing some algorithms. I'm not sure. I mean, it's kind of different from doing streams like this. You want some tutorial. I mean, there should be quite a lot of tutorials, in fact, on many topics. So I think that what makes maybe these streams different, but I'm not sure about that, is that like I'm doing them kind of live, but also I'm doing them competitively. So I guess that's like the only way it can be done both live and competitive at the same time is like doing it like this. So I guess that it should also be like maybe helpful for, I don't know, just seeing what you could aim for. Nice t-shirt, thank you. Yeah, great source for problem solving. Well, hope so. Nice. Yeah, okay. So can I do a typing speed test? Perhaps after the contest, because we have... Oh, maybe I should... Yeah, which one do you recommend? Maybe I can warm up. But in fact, I don't think it will be impressive, because typing code and typing English words is kind of different skill. Ready to get over me fa fa oh whoa on leaderboard. I wonder how you pronounce it correctly. I mean, I obviously was not supposed to get glow, right? Okay, that's a joke. Anyway, I'll try. Play type racer from. Okay, I guess if I have enough time. It would be sad to be late. Okay. Those ads are weird. Okay. 1:13 WPM. Actually, no mistakes is not quite what I usually do. I think I do a lot of mistakes usually, especially in Russian. I think that actually typing in Russian is faster for me because I used to use a lot of Russian chats. Anyway, okay. Humanbenchmark.com. Maybe I'll try it after the contest. So I guess I should start soon. We have 28 viewers and 4 minutes before the end. Oh, okay. Okay, let's wait for maybe 2 more minutes. Then I'll start at 21:58 local time. Best of luck, thank you. Best of luck to me. I guess I don't have donations yet, so I have to use all open strategy. Sometimes blind submissions are good, but I guess that in long term, if you're competing like in a series of 5 rounds, they're mostly doing bad things, at least for me. No way to donate. Keep your money. That's fine. So 40 seconds. I'll close the chat then. 30 viewers. Okay, I guess actually it grows usually. Also, this time we don't have another stream, I guess, from Amnik, which commentates on me. So, well, should be fine too. So, 15 seconds. Okay. So I guess I'm ready to start. Nice picture on CF, thank you. 5 seconds. Okay, thank you. See you in 80 minutes or before later. Let's start. This one looks weird. Forgot the most important thing. Sorry. Oh, okay. That was so important. How could I forget? So, okay. Let's go. Sorry guys, had to leave. Yeah, I'm far behind. Okay. Guess I have to do something. Oh. So bad.
checking. That's so bad.
Okay, guys, this is gonna be the most educational stream ever. This one will educate you how not to do contests. Wow. I was so bad. Is anyone still watching? Okay, 72 people. Nice. What are you watching though? There's nothing to watch, right? Okay. 14th place, okay. Oh, well. I don't know. Okay, I guess what I can do at least is to solve the rest of the problems on stream. So, yeah, I guess I cannot view your discussion, but yeah. I just had bad day. Okay, hope so. Well. What is happened? I just failed. Well, okay, so problem A. In problem A, no, that's just water. But yeah. Okay, yeah, the colors are updated now. That's how it is at the end of the contest. But Kevin solved 6 problems and I have solved 3 problems. Well, makes sense. So, problem A. What's wrong with my problem A? Any ideas? Runtime error. Oh, what do you think? So, I mean, problems, I don't know. So, I guess I still don't know how to solve F for some reason. So, as I could get the problem statement, it seems that I just have to check for each vertex whether it's, so I am given a, well, directed acyclic graph, and for each vertex I have to determine whether it stands at the same positions in all top sorts of this graph. Right? Is it the problem statement at least? I don't know. Is there anyone who solved the problem here? Maybe you can help me out. Oh, we found another Easter egg. Turns out it's not only 11, it's also 13, but 12 is just 1, 2 for some reason. Yeah, the problem statement is quite complicated. Right, okay. So my first idea was to kind of simulate top sort process, and I wanted it to, like, if a vertex is alone in the queue at some point, then I just know that this vertex is the, like, has to stand at that point, but it's not exactly right. For example, like the first test case I came up with was like this. So I have two edges 2, 4, and 3, 4. And if I just do it with Q, then vertex 4 stands at like position 4, because I just take 1, take 2, take 3, and then I take 4. And then the moment I take vertex 4, it's alone in the queue, so it's just incorrect, I guess. And my second guess was that if I find the lexicographical minimum, top sort and maximum top sort, and then I just compare them somehow, then maybe I can figure out the answer. For example, if I have a vertex at the same position in two top sorts and the prefix and suffix contain the same set of vertices, then I claim that this vertex is like good. It always stands at the same position. But again, I don't know. It was kind of a guess. I don't know whether it's incorrect. Do you have any counter test, or maybe I have a bug in implementation, but not very likely. And maybe the solution should be entirely different. So one idea was that, yeah, another idea was that basically for each vertex I have to check whether I can reach any other vertex, or yeah, okay, that's what right. So yeah, for each vertex I have to check whether there exists another vertex, so that you cannot reach either from the other one, right? Yeah. So yeah, for all vertices U, I have to check. So yeah, for each vertex V, the answer is I have to check for each vertices, for all those vertices U, either V is reachable from U or U is reachable from V, right? My solution is not doing similar to that. Yeah, okay. So that's what I thought as well, but then how do I do this? How do I check that condition? I mean, I can find the set of vertices that are reachable from each vertex using some kind of, well, bit set, I guess. I guess I don't need bits. I don't know. Maybe I do need. So if I just use bit set, then I run out of memory, right? So it's not good. And what should be the linear or near linear approach? Maybe I should think some more time about it. I don't know. Okay, so running through the problems. The problem C. For each, I had to sum some integers in the range from L to R that have k as the minimum integer divisor greater than 1. Yeah. So winning numbers are all single, well, integers x, so that k is their smallest integer divisor greater than 1. So basically, it means that k should be prime first, and then if k is prime, so we want an integer is winning is if it doesn't have any prime divisors less than k, right? And I have to sum up all these integers k, all these integers x in the range. Oh, okay, and then I guess that the solution should be like something along the lines of summing primes in the range. So, I mean, it used like, I guess I even remember a problem from top quarter. No, incorrect login. What's the correct one? I don't know. No, I guess it's top quarter login, right? Oh, Luciana 2018. Okay. So, yeah, maybe I should have looked it up during the contest, but I don't know. But basically, I guess that this problem asked to I don't know. To sum primes in the range. So when you want to sum primes in the range, you have the dp like integer and prime, so 2 parameters, and then you, I don't know, there's some easy formula to recalculate it, and then the upper bounds, the values of n, the values of bound that go to calc are all of the form n divided by something, where n is the given integer, and the number of such bounds is square root of n, right? So, but still, this is slow, right? Yeah. Whatever. What's up? No one is active in the chat. Uh, what do you want me to do now? I guess I have to solve the problems, but I'm just lost a bit. Well, so problem A was kind of standard, I guess. Well, not standard, but just you need some data structure, and then you realize that that data structure is the dynamic convex hull. But then I have some kind of runtime error. I'm not sure where it is. Okay, here it is, I guess. Maybe that was the bug. Did I go to the next round? Well, this series is not... Oh, almost a nice submission ID. This series is not advancement to the next round. In this series, you just solve 5 rounds, and then the results are getting accumulated. So this is the website of the series, and then it has series standings. And each round is GP 30, so the winner gets 100 points, the second place gets 75 points, the third place gets 60 points, and so on. And then we get the sum. Okay, that was the bug in problem A. Cool. So, yeah, could have been 6 then. If it passed, then I would have been at 6th place. 6th place would have been not too bad for me today. Okay, so how to solve problems C and F? Any hints? Yeah, okay, so my approach at F is totally incorrect, I guess. Is the audio chopping? I don't know. Hopefully it's from your end, but I'm not sure. I think the setup is the same as it used to be. Okay, so how are such problems solved? Hi. Let Sn denote the sum of primes that are less than or equal to n. We can compute the sum of primes in each of our intervals by computing Sn for the S squared Tx values of n. I guess that comes from the problems. It's from the problem itself. Yeah, T and X is the sum of all numbers between 1 and n that do not have any factor between 2 and x inclusive. Okay, so I guess that this is exactly what we need. Well, basically not, but So if we have, so yeah, consider this definition. We have t and x, the sum of all numbers between 1 and n that don't have any factor between 2 and x. So in this case, the answer to our problem is it will be t and yeah, so we are given n and k. Well, we aren't given r and k, but obviously answer for lrk is equal to answer for 1rk minus answer from 1l minus 1k, okay? And then answer for 1nk is equal to, if we have this function, then we have t n k minus 1 minus t n k. So basically t n k minus 1 will be the sum of all numbers that don't have any factors less than k. And then I should subtract the number. And then I have to make sure that they have a factor equal to k, right? So I also have to subtract numbers that don't have k as well. So I guess this will be correct. And then the question is just how to find t and x. You think that I should delete memorization? Actually, yeah, I had a bug at first, and then I saw that the problem was that I had it. And then also my solution isn't correct still, I guess. But anyway. It doesn't look faster. I think it, no, I think it should be too slow. Will it even be like polynomial? I don't know. Yeah, probably polynomial, but I don't know. It shouldn't be too fast in this case anyway. Well, anyway, so. Okay, at least I forgot to multiply it by p pos, right? So t and x is, if x is equal to 1, it's n times n plus 1 over 2. So here it is. And then tn p is equal to tn p p sharp p prime minus p times t n divided by p. Okay, so you mean that here I should go like this? Maybe. I don't know. I mean, it should be still too slow. No, I don't think it will be fast enough. I don't know. I mean, it's still incorrect. Maybe I should fix it first. But then I'm kind of trying to guess the solution. That's not too good for me. If k is large, then r divided by k is small, so it should work fast. If k is small, it should work in... Oh, okay. Okay, so this one says that if we precompute answers for n less than square root of x, I mean, nice code formatting. Yeah, I guess I'm just so bad at this. Where are the problems? Yeah, here's the problem. Here's it. Oh, maybe I can, by the way, fix this one. Yeah, I have 4 problems now. I mean, I can describe the easier problems, but I don't know how to solve F yet. And then I'm pretty bad at understanding what happens in problem C as well. Maybe I should go for the easier problems and then, but I guess that I will not get any help from anyone for harder ones. Okay. Anyway, so just to look at the easier problems. So here were the easier problems. So problem D was the easiest, I suppose. It was. In problem D we had a wagon painted by N designers. Each designer decided to color a strip of length Li starting from the beginning of the car or wagon, I guess that's the translation. But it's the same thing, so and then some works are completely painted over, but some are still visible, at least partially. And I am given, like I have N designers. Basically, we can describe it like this. So we have a thing, so it's a car, I guess. It's a nice car, right? And then we have several people, so each person comes and then colors some part of the car in some color. So first, like the first people comes and then the first person comes and colors like the first part in red. And then comes the second person and I can color the like I choose some part like some prefix again and color into yellow color, and then what happens is that this part is not red anymore. So now I have two colors, yellow and red, and then let's say that the third person colors the prefix which is longer, and then it just colors all of this in green, and then all of this is not yellow and red anymore, and then I can say that I have only one color visible here. So the question is, I am given the strip lengths from 1 to n, and then for each strip length, a person comes who colors a strip of this length, and I want to know the number of different colors I can see after each coloring. So here, if I have a person who colors like a length 1, I have one color visible. Then another person comes who colors a prefix of length 3, and then the part of the first person gets covered. So I have only one person now, and then only one visible color now, which is the color of person 2. And then the third person colors just the prefix of length 2, so I can still see the prefix of the second person, and so I have two prefixes seen now. So yeah, the solution was like this. So I have a data structure. I have set in this case, but I can just have a stack as well. It doesn't matter. So the stack or the set contains the elements, like these are the lengths of prefixes that can be seen at each point. So for example, if set contains integers 4, 6, and 7, it means that I have a color scene which has length 4. Then I have another color scene which goes from like position 4 to position 6, and then I have the third color which goes from position 6 to position 7. And then when I get x, obviously all prefixes which have lengths less than or equal to x will be covered, so I erase them, I remove them from the set, and obviously I can just go from the first position to like from the smallest prefix to the larger ones. So I erase all of them and then insert x, and then I'll put the size. So basically that's kind of it. And then the question is how fast it is. So I have two cycles here, two loops here, one for loop and one while loop, but every time I go inside the while loop, I get one element removed from the set, so I have at most n elements added to the set. So I have at most n elements removed from the set. So this is linear time times the complexity of the set. This complexity of the set is log n, so it's n log n in this case. But if I use the stack, it would be just n. Anyway, that was it. Okay, let's go to see what we have in the chat. So you don't need these tricks for C. You can do straightforward inclusion exclusion and it will work fast enough for this problem. Well, I thought so. I'm not sure why. I mean, maybe. It's kinda... I mean, so if k is small, then I can have... If k is small here, I can check all smaller primes and then just do like inclusion exclusion, right? On these primes. But if k is larger, then I have a lot of primes smaller than k. But then maybe the number of primes is... Yeah, maybe the product will all overflow quickly, and then yeah, maybe this way works. But for some reason I thought it will not work. As the contest is now over, yes, I think I will solve problem C sooner or later today. It's not exactly like my thought process anyway. So in problem F, if I think about a different approach, Kevin thinks I can get it. Okay. Let's find any top sort, and I have a position of U. U is good if for each V with odd V less than odd U, there is some... Yeah, okay, I see. If K is large, then R divided by K is small, and I check X at most one time. I mean, still, so... Yeah, I haven't understood the solution for F. Anyway, so the problem is... So yeah, if K is large, then R divided by K is small. Okay. So what's the complexity anyway? I check all X at most one time, right? So the complexity is the number of integers not exceeding R divided by K that are a product of primes, like distinct primes less than K, right? Is that the complexity of just brute force? Well, maybe. I mean, yeah, okay, I can try to implement it, but I just wonder. Maybe let's just try. So basically, again, so the problem is count integers from L to R, which have K as the minimum integer divisor. So again, I want to check that K must be prime. I mean, yeah, okay, so this is the complexity. If this is the complexity, so for how can we estimate it? Do you have any like ideas? Because in the things like when you count like primes or you sum primes in the range, then it's like R to the power of 2/3 or R to the power of 3/4, right? In general, but this complexity doesn't look like anything like that, right? For me at least, because if R divided by K is, well, I mean, the worst case, I mean, one part is that R divided by K is small, but then in the left part in the other part I have I have to brute force all integers. I don't know, it's just hard to estimate for me. Anyway, so I have to check that K is prime first. Otherwise it's 0, the answer is 0. And then So let's see. Also, yeah, okay. So suppose, so it works in very not tight bound. Yeah, something like that. I guess I should just believe that it works quickly. So this, what's the solution? The solution is, in this case, if k is equal to 2, for example, if k is equal to 2, so the answer is just, yeah, so I'm solving the problem for nk. I want, the problem is some integers x not greater than n, such that k is their smallest integer divisor greater than 1. So if k is equal to, yeah, okay. And, oh, I'm so bad. Sorry, guys. Yes. So first, all these integers have to be, yeah, so that's the problem. That's what I will be solving, okay? So I will just output solve rk minus solve l minus 1k, okay? And then I also can have the modular integer because I have to output the answer modulo something. And then again I have this function which outputs sum of integers such that k is their smallest integer divisor. Okay, so the first idea is that this integer, all these integer x, have to be divisible by k, right? At least. So suppose that x is equal to k times some other integer y. I want, so what should be the condition on y? Y must not contain integer divisors between, like, in the range from 2 to k minus 1. So that's the condition on y, because if y has a divisor in this range, then obviously x has such divisor too, and also k is guaranteed to be prime when I call solve. And if y does not contain any integer divisors in this range, then it's fine for me, and I don't need to, like, yeah, any such y will do. So basically, I have some upper bound on y. It will be n divided by k. And now I want to find sum of integers y at most max y, such that, like, that don't have integer divisors into k minus 1, okay? That's what I want now. And then I will multiply this sum by k, and it will be my answer. And the idea is that we can use inclusion-exclusion in this case. So let's find all primes in the range from 2 to k minus 1. And since we don't want y to have any primes in this range, we'll just, for example, if k is equal to 5, I don't want y to have integer divisors like 2 and 3. I don't want y to be divisible by 2 and by 3, but any other primes are fine. So I can just find sum of integers which are divisible by 2 and subtract them from the total because they are bad for us. Then I, for example, if I have just 2 and 3, I subtract all integers that are divisible by 3, and then I have to add the sum of integers divisible by 6, because all such integers have been subtracted twice if I subtract those divisible by 2 and by 3. So here I will have inclusion-exclusion. On what integers? So yeah, I guess I can also have if k is more than n, then the answer is 0. If I have to do this because otherwise it can overflow. So I want, if k squared is more than n, then only k is the answer. So now k doesn't exceed square root of n. So we can just find all primes less than k. This way, I just find all primes less than k, smaller than k. What next? I want to do inclusion-exclusion on these primes. So I will just go with some, well, recursion. Int will be the position, and lon will be, well, the product of primes I have chosen. Position I and products. So I run dfs01. Okay. If I is equal to p size, then I'm done. I have to do something here. Otherwise, I can ignore the integer. Yeah, and also I have to I guess I have to subtract in the other case, so let's return something here. I can do it like this, and then if I ignore the integer, I go to I plus 1 product, and if I don't ignore it, but actually use it, then I go to product, like my product is multiplied by pi, but I don't want it to exceed max y. So if it doesn't exceed max y, I go like this. Okay. And then here, at this point, product is a product of like some primes. So I have some primes here, and I have to return the sum of integer divisible by this product, and not exceeding max y. So the number of such integers is max y divided by product. The sum of all integers from 1 to... now I have to sum product, 2 by product. If product... Okay, I will do that, I think. So I want to find the sum of this. Product 2 times product and CNT times product. Sum will be equal to CNT times CNT plus 1 divided by 2 times product, I guess. And then will be my answer. Okay, so at least this should work. Maybe it will be slow because of... I don't know, because of what? 96. 96 cannot be correct. I have to subtract 1, I guess. Because 1 is... No, I have to multiply by k here, right? Yeah. Yeah, I forgot I have to multiply by k. So 125, 125, 5. Okay, 135. 135.5. Okay, it looks at least somewhat correct. Yeah, it's still quite slow. But what if I have a small prime here? Well, it's not bad. Yeah, so if product times pi is not more than that, then not more max y, I return here. That's what I do now. But otherwise, that's like, this is equivalent to what my code does, right? So if product times the next prime doesn't exceed max y, I just go to two different calls of DFS. But if it does exceed max y, I like don't have to go to I plus 1 because the primes are sorted in increasing order. So I can just jump, as there says, to the last position in my DFS. I can just skip all the rest, like all the remaining primes, because they're just irrelevant. So I guess it works quickly, but I just, well, I can even submit. But we can, like, it's still hard to estimate the complexity, right? But I guess if we have, if we check all possible, like, at least the complexity depends on n in like monotonic fashion. The larger is r, the worse is complexity. Yeah, like not complexity, but the number of operations. The complexity is the same. 99 milliseconds. I mean, wow. I don't know. I guess I can check that for all possible k's and then all possible values of k. And then it will be fine, but yeah, it's hard to estimate. And also the bad thing here is that I still haven't learned how to find the sum of primes because I just did some kind of inclusion exclusion. But I guess I should understand this later. Because actually during the contest I did something like that, but it was just too slow, right? But I assume that with a good implementation it should be fine. Maybe my implementation was not good enough. Does code runtime matter in competitive programming? Uh, it doesn't matter as long as you satisfy the limits. So in this problem I have a time limit of 2 seconds. If my solution ran for just 99 milliseconds, so it's like 20 times faster than needed, but it doesn't matter as long as it's fast enough. But what I tried during the contest was not fast enough. It was slower than 2 seconds. So yeah, you don't get any profit from faster code in general if it's quick enough. In prime counting, I have to do sweep line with bit. That's correct, but there are two problems, similar problems, but I think they're different. One problem is prime counting. In prime counting, I guess I have to do sweep line, but there's also prime summing. And when you want to find the sum of primes, you don't need sweep line. I believe. I believe you just need some formula like this. Actually, during this single round match, I even looked up some implementation of prime summing, and it was just very short. And yeah, definitely didn't have any sweep line. Anyway, hooray, I have 5 problems now. It's been only 45 minutes after the end of the contest. What about problem F? Well, maybe I should return to easier problems just for a change, just to relax. So problem B. The problem statement is pretty bad. I just don't really understand it, but when I looked at the samples, I understood the problem statement, so it's quite weird. Kevin gave some comment on F. Well, Kevin said that I have to think about different approach. Then Kefa gave a comment. Yeah, I'll take a look a bit later. Anyway, in problem B, I had 2 to the power of n integers given. And basically, the question is, like, the problem is, I had some integers a1, a2, an. I'm given sums of all subsets. So, for example, if n is equal to 3, I'm given 0, a1, a2, a3, a1, like a1 plus a2, a3, a1 plus a3, a2 plus a3, and a1 plus a2 plus a3. So, for example, if n is equal to 3, I am given 8 integers as follows, all possible subset sums. And the question was, when I am given only these integers, restore a1, a2, an. That was the question. In this problem, I had to restore the initial n integers given all possible 2 to the power of n subset sums. Or say that it's impossible to restore them. So the solution is not difficult. Basically, notice that I have a 0 always, right? And since I have a 0, well, it doesn't matter, right? But all my integers, yeah, the important condition, which is, I'm not even sure it's actually given here, but well, it's actually not super important, but it's kind of important that all integers a1, a2, an are non-negative, I guess, or probably even positive. But if some of them were negative, then the smallest possible subset sum would not be 0, it would be something different. It would be the sum of all negative integers. And yeah, it would be a bit different problem, but it would be still solvable if integers would be allowed to be negative. But here they were not, I suppose. At least that's what I assumed, and I passed the problem. But I'm not sure it's described in the problem statement, so the smallest subset sum is 0, but the next smallest subset sum will always be a sum of just one integer. Because, well, the sum of like 2 or more integers are always greater than the sum of like choose any one integer and then this integer will be smaller, right? Because all integers are positive, and that means that the second integer, if I sort all the given values, the second integer will always be the one of the given integers, one of the integers I have to restore. So that's what I do. I sort all given integers and I restore the, well, here I call them B, not A, but doesn't matter. So every time the next integer I have restored is the, well, the second element, since we have 0 in this indexed arrays, it will be A1. That's the next element I have. And then what I have to do here is notice that, for example, if I have found A1, it means that if I have found A1, it means that I have sums 0, A2, A3, A2 plus A3, and I also have A1, A2 plus A1, A3 plus A1, and, well, A3, A2 plus A3 plus A1. So, I mean, I have like the set of all integers I'm given is all subset sums without a1 and all subset sums with a1. And if I could split my given set into these two sets, the one containing a1, all subset sums containing a1 and all subset sums not containing a1, then I can solve the problem recursively or like inductively. I just go to the subsets, I take all subset sums without a1 and just do the same thing. But now I have one integer less, so eventually I will have only like one integer remaining. I'll have two subset sums, 0 and that integer. So it's like induction, but an easy addition of induction. So I have to split the set into two sets. If I do that, I just win. How can I do that? Basically just go through integers in, again, in non-decreasing order. And I store new a. New a is exactly the set of, like the new set of all subset sums without the found integer. The found integer is bi in this case. And s is the set of integers, like multiset actually, that should be erased from a. So basically I go through all subset sums in increasing, like from left to right in non-decreasing order, and for each sum I try to find it in the set. If it's in the set, then I just erase it from the set, or if it's not in the set, then I realize that this subset sum does not have a1, but then I know that I have a subset sum which is equal to aj, like this integer, plus that a1, which is vi actually. So I insert it into the set. So, I mean, I guess in this case, code tells better than words. But yeah, I suppose that's just the way I do it. If the set is not empty in the end, that means something went wrong. So it's impossible. Otherwise, I can be sure that new a will contain exactly 2 to the power of n minus 1 integers, or a minus 1 minus I integers actually. And I can just set a to new a and just find the next integer and so on. Something like that. So the main idea is that I can easily find one integer, and then I can also separate the set of all subset sums into those containing this integer and those that do not contain this integer, and solve the problem for the rest of the integers. And so on. That's it. Hopefully it was understandable, but you can ask any questions. In general, what do I do to relax and get out of stress in such situations? You have it in every contest. You mean that in every contest you... Yeah, I guess everyone runs into such situations, right? I don't know, just do what you can. I mean, at least this time, definitely I am not a good example of what should be done. But basically I had problem F, which I had an incorrect solution to, and then I had problem C, which I didn't understand really, and then problem A, which I knew the solution to, but yeah, I just didn't want to implement it at first, but maybe I should have done it like quickly. Anyway, I mean, just do what you can. Just the answer to a question like how to relax is just relax. Like what? There's no like recipe how to relax. Just don't worry. I mean, just try to perform as good as you can. Just try to do whatever you can solve. Just solve it, and don't worry if you cannot. I mean, if you cannot solve it, then make sure to solve it after the contest and try to progress from there. What topics should I learn to become master on CF? I'm not sure about the set of topics. I don't think there is any specific set of topics so that if you learn them, then you become master. If you don't, then you don't. And also, learn a topic is a very vague definition. You cannot just learn max flow. I mean, for example, it's not like you just learn something and then you can solve all problems about this topic. It's not this way. It doesn't work this way. In each topic you have easier concepts and then harder concepts, and then in general problems require thinking and coming up with like solutions, ideas, and it's not like there can in every topic there is a problem which I cannot solve. So I guess I have like I guess I know topics, but still there's always something. Nice Ava. Thank you. Please absolve J2 on stream. Yeah, J2, for those who didn't know, J2 is a problem from Petrozavodsk camp of last summer. It's from Ildar's contest, so he now advertises his own problem. I guess it will take some time. Yeah. Yeah, how would I solve B if I had negative integers in the array? Sure. So I guess I can show an example in this case. So let's say I have integers -2, a equal to -2, -3, and 4. Okay. What will be the set of subset sums? So it will be 0, -2, -3, -5, 4, 2, 1, -1, right? If I sort them, I get -5, -3, -2, -1, 0, 1, 2, 4. Okay? That's what I have. Suppose that I, instead of -3, like -2, -3, and 4, I had 2, 3, and 4. What would be the subset sums? Actually, it's easy to understand. It will be like 0, 2, 3, 4, 5, 6, 7, 9. And if I just look at, oh, hello, a party of 98 raiders. Cool. Hello, everyone. Hi. This time I know what raiding is. How was your stream? Competitive programming in PHP. Never done that, but that could work. Are we doing vector math? Not really. So what I'm doing is I am solving competitive programming problems. In this case, I'm solving a contest called Snark News Winter Series 2020 Round 3. It was okay, was not doing boring non-competitive programming. What were you doing? Were you doing competitive programming in C++ in PHP really? Or what? Or were you just playing games? I don't know. What did you usually do? Ah, was doing. Okay. Okay. One more raid. Last miles. Double raid. Cool. 41 more raiders. Anyway, so hey. Did you know web dev? Hi everyone. I haven't done too much web development, but at some point it was 2009. It was 11 years ago. Well, that's a lot. Okay. Actually, I wanted to make a website for training with my friend. We actually did actually created a website in PHP, but it was so bad. I mean, I guess the main thing about this website is that all the data was stored in text files instead of like databases or something like that. But given that we had like 10 users, that was fine. I guess the probability of race condition or something was pretty low. So yeah, I have done some PHP, but I'm not good at it. Are you good at PHP? I mean, actually, are all of you watching those streams like coding in PHP? I am probably not. Maybe you just want to know how to do it. I don't know. Maybe not just PHP. Whatever. So here I was solving a problem and I was answering a question. You tend to stick to C to make life easy. Is C easy? Do you mean C++ or C? I actually wonder. And also, well, actual C. Okay, that's cool. That's cool. So yeah, the problem was I had I had several integers which were hidden, and then I was given all possible subset sums of these integers. I had to restore the integers. That was the problem I was solving and explaining here. And then I explained the solution when all integers are positive, and then when I have some negative integers, actually what changes is that all subset sums are changed by the sum of all negative integers. So here I have 0, 2, 3, 4, 5, 6, 7, 9, and here I have all the same integers minus 5. So if this is A1, S1, this is A2, S2, then S1 is all x minus 5 for each x in S2. That's it. So basically, if I just shift, so the solution with negative integers is just shift the set so that S0 is 0. So for example, I will transform S1 to S2 in this case. Then solve the problem for positive integers. Then I have found A2 this way. And how to go from A2 to A1? That's the question. And the change is that I have to negate some of the integers. And the solution is that I have to negate some integers, like negate some integers with their total sum equal to S10 minus S10. So in this case, I would go from S1 to S2, solve it, I will have 2, 3, 4, and then I have to negate some integers, and I just have to find any subset with the total of 5. And then the only subset here is 2, 3. I can just negate 2 and 3, and I will get negative 2, negative 3, and 4, and that will be the answer. That's the solution. Well, do I prefer Windows over Linux? Well, yes and no. I mean, I am used to Windows. I'm just used to using Windows. And, well, in general, in like complex programming, it doesn't matter too much, I think. You just use whatever is comfortable for you. Show the score table, please. That's so bad. Don't make me do that. Well, whatever. I guess I have to... Yeah, that's how I did today. Yeah, 14th place. Do I prefer Windows over DOS? Yeah, I guess Windows are nice. Windows are nice. I think so. You can have a nice view through the window. Usually you don't have a nice view through the door, unless the door is transparent, right? Using doors. Is there like doors OS? Do you use Midnight Commander using under Linux? Not really. I mean, I had no. I think Midnight Commander is. I think it used to be worse than Farm Manager at least, but maybe now it's fine. Doors sounds like DOS. Yeah, it does. Who goes outside anyway? Yeah, but if you go through the door, you don't see the door anyway. So, doors are not necessary, I think. Why all sums are shifted by sum of negative? Um, well, so uh, let's say I have. What are all subset sums? To get a subset sum, I have to pick 0 or a1, like or minus 2. In this case, I have to pick 0 or minus 3, and I have to pick 0 or 4. That's like how I get a subset sum, right? So if I make a choice in each of these options, I get some subset sum, right? And let's say that instead of picking like 0 or negative 2, I choose from 0 plus x or negative 2 plus x. Then whatever my choice was, my sum will increase exactly by x, right? And it just means that I can just shift whatever. So if I just shift in every such choice, if I shift it by x, I will shift all possible subset sums by x if I shift all two options, like both options. So, and in this case, if I shift 0 or minus 2, shift by 2, I will have to pick from 0 or 2 or 0. And if I shift by plus 3, I will pick from 3 or 0. And here I just don't shift. So now I have pick 2 or 0, pick 3 or 0, and pick 0 or 4. And I have all subset sums shifted by plus 2 plus 3, so plus 5 in total. That's kind of it. How did I prepare for my first IOI being 11 years old? Just like everyone, I don't know. I'm not sure what to answer here. What do you think competitive programming has that makes very smart people want to keep playing instead of going to the best companies and be software engineers? I mean, I suppose that, well, I mean, it's personal for everyone, I believe, but in general, the reasons should be that just it's more fun in general. So you just learn something new every time, I guess. I mean, you do learn something at software engineering as well, but it, just it might be like, I don't know. It's just different. It's just different, I guess. Yeah, so this stream turned into a QA session. I guess I should have expected that. That's fine. Do I play Dota, LoL, CS, or PUBG? I don't play any of this. I used to play some Hearthstone, but well, not professionally. What time do you usually sleep? Mm, what time or how long? I don't know. It depends. I don't have a strict schedule. I just sleep any like Sometimes I sleep a lot, sometimes I sleep not so much. That's not good for health. I guess I would love to have a strict schedule, but sometimes it doesn't work. Yeah, sure. Any routine that you like to strictly follow? Yeah, probably not. I refused Google to continue winning contests. I mean, I think yes. What that yes? I'm not sure what's the answer, but anyway. What is my name? Oh, is it never mentioned? I guess if you look at the Twitter panel here, it shows my name, right? So it's Gennady Korotkevich. What do I eat and how frequently? What's bao? I don't know that word. And well, I eat food. I don't know. What team will I support in the World Finals? Uh, well, I don't know. I still don't know all the teams. I I guess I'll support like Russian, Belarusian teams in general, but that's not like supporting hard. And well, I mean, I am doing some small bit of coaching for Eat More team this year. So I guess I'll support them for sure, but we'll see. What do you think? The question was, what do you think competitive programming has? So the answer is not yes. I guess the answer should be what. Anyway, the next stream is planned to be in 6 days. In 6 days, we'll have round 4. Hopefully I perform better than today. But maybe that's not necessary. Maybe when I perform badly, that's actually more educational. I don't know. Which inside is my favorite? Ooh, I don't know. I like all of them. All of them are different. I wouldn't like to choose all of them, for sure. Google Code Jam, Facebook Hacker Cup, Coder World Tour Finals was only held last year. And also there are some teams. Coach Chef Snackdown was fine. Was actually pretty good. It's sad that we have no Coach Chef Snackdown this year. VK Cup is going to be like revived this year. That's cool. Top Coder Open is definitely a very good event. So I would recommend any on site for sure. The one where I win. That's sure, but that's not well. Yeah. Anyway, must rate my fridge. Yeah. Do you rate your fridge with 40 viewers? Probably not. I am participating in Google Hash Code. Yeah, I guess I am. Last year we won it with Boris Minaev and Niasnik Matulin. And I think we'll try to do the same thing, but maybe something will change. We'll see. We'll still have a month. Do I do Advent of Code 2019? No, I didn't do it. Did you like it? I heard about it, but I never felt like doing one problem a day. So from today's problems, I have described the solutions to... Well, I haven't described my solution to problem A, but I don't feel too much like that. It's kind of... Anyway. It's quite hard. It was fun. Okay, good to know. Advent of Code 2019. So this problem is, so this is something like first to solve. So if you solve it faster than others, then you get 100, right? How do you get 3500 if you have 25 problems and 100 points each? Oh, hello, Kevin. Yeah, I mean, the one problem with this type of events is that you have to come at the same time each day. Oh, both stars. Okay, there are 2 stars each day. I see. Or not, I guess. Anyway, I mean, yeah, it's a bit hard, so you have to schedule accordingly every time if you want to compete. But, well, maybe just doing for fun should be fine. I mean, totally not anything against it. Anyway, problem E. Yeah, problem E. I haven't described problem E. That's true. Oh, well, okay, let's do it. Why not? So, problem E. Yeah, so here's the problem statement. I guess you can try to read it and try to understand it. It's not really, well, it's not hard, but so in this problem we have n like segments, just n line segments, like straight sections called here, and we want to build 2 polygons from these line segments. Each polygon should have a non-zero area. Each line segment should be used exactly once in these polygons, and well, the sections should be used as a whole. And we want to the perimeters of the polygons should be as close as possible to each other. And I want to find this minimum difference, or determine that I cannot construct 2 polygons from this set of line segments. That's the problem. So for example, in this case, if I form 2 triangles, one triangle of sides 4, 4, and 5, and the other one is triangle of sides 4, 4, and 4, I get difference of 1. And here I guess I can make 2 polygons. I guess one polygon could have sides 3, 2, 1, 1, and the other one could have sides 3, 2, 3, 2, but I don't have to use the consecutive segments. I can use any of those. And here I have 6 segments, 1, 1, 1, 1, 1, and 10. And 10 is just too long. I mean, I cannot form a polygon if I have a long segment of length 10 and then I have 5 segments of length 1. I just cannot close the polygon, so I cannot use it here. That's why the answer is -1 here. -1 means that I cannot build the 2 polygons. So the solution to this problem is, well, first I have to realize what is the condition when I can build a polygon. This is kind of well known, I guess. So if I have sides x1, x2, and so on, xm, let's say I have m sides, x1, x2, xm, and they are sorted in non-increasing order, then a polygon can be built if and only if xm is less than or equal to the sum of the rest of the other sides. So no, it should be strict here. So for example, we have a triangle inequality. In a triangle, if a less than or equal to b less than or equal to c, then a triangle can be built if C is less than A plus B. And so this is just kind of generalized triangle inequality. Right? So that's the condition when we can build a polygon. That's one part of the problem. And another part of the problem is, well, how do we, like, we have to split the set of line segments into two sets so that their, like, perimeters, their sums of lengths is like as close as possible. And for example, let's forget for a while that we have to be able to build a polygon. Let's just split the set into two subsets which have totals as close as possible. But we don't have to build a polygon from each subset. Let's solve a problem like this. And okay, so let's split A1, A2, AN into two subsets so that the sum of subsets I modular difference is minimized. Okay? And also, well, let's call this subset P and subset Q, and then P union Q, well, it's cup, right, is equal to A, and P cap, I don't know, P union intersect Q is empty. I'm not sure about latex. I every time I try to use LATEX things, I have to look them up on the internet. I just don't use it too often. So this is the set. Okay. So this problem is a kind of knapsack problem, which is kind of well known. Be sure to look it up if you don't know. So we just use dynamic programming in this case because the lengths are small. The lengths are just at most 100, and all the lengths are integers. So we just can use some kind of dynamic programming in this case. So we'll have a, let's say, function of I, and sum is true or false whether we can pick a subset of A1, A2, AI from the first I elements with sum equal to total equal to sum. Okay. So this is kind of, yeah, how do you calculate it? So it's equal to fi minus 1. So first we have f0, 0 is equal to true, and f0 sum is equal to false for sum not equal to 0. Okay, that's the base condition. And then for each I can either choose AI or not choose AI. So if any of this is true, then fi sum is true, otherwise it's false. So that's what I can do here. And then let S be the sum of all integers. And the solution is find sum such that f and sum is equal to true, and sum minus s minus sum is minimized, because I just find the first subset. So sum, in this case, I will find the sum of the first subset. It will be sum. The sum of the second subset will be s minus sum, just whatever is left, and the difference wants to be minimized. So I just follow this problem statement kind of. So that's how I split it into two subsets which have the smallest difference. And the complexity of this solution will be the complexity of this knapsack. It will be n is the first parameter. The second parameter is n times L, where L is max AI, because the sum is at most n times max AI. That's fast enough in this case. So what is left here is that we have to actually use this condition. We have to build a polygon from the subsets. That's important. You cannot just form any subsets. And let's just use this condition. So first, suppose that we sort suppose that we just sort integers. We have a1 less than or equal to a2 and so on. So obviously in one subset, in both subsets we are interested in the longest side. We want to compare the longest side to the sum of all the other sides. So in one of the subsets, obviously the longest side will be an, right? An will be the longest side. And in the other subset, we'll have some different side. Let's say that one subset has max side equal to an, and the other subset has max side equal to ax. A, where x is so these conditions, because we have to have at least 3 sides. So at least 3. To form a polygon, we need at least 3 sides, and x should be less than n. So at most n minus 1. So now if we fix x, if we choose the maximum side of the other subset, we can just, just kind of solve the problem again, but we just now we can check the conditions. So now we want to split a1, a2, ax minus 1, ax plus 1, and an minus 1. So basically we split the set of all sides except ax and an. We just ignore them into 2 subsets, so that again, like P and Q, and also P and Q here, we again want P union Q to be equal to this, A prime, and P intersect Q to be empty. And we want to be able to build a polygon, so AX should be less than the sum of L elements in P, and AN should be less than the sum of all elements in Q. And again, we want to minimize something. So first we want sum P plus AX. That's the sum of the first subset, and the sum of the second subset is sum Q plus AN. And we want to minimize this. That's it, right? So basically that's how we have transformed our problem. And yeah, now we can do it. We just can use the same dynamic programming, the same function, the same f. So we'll be using the same dp. So we just find a sum such that fx minus 1 sum is equal to true. So here sum is sum p. Yeah, so basically we just find the sum of subset p, so that fx minus 1, we can build this sum on the prefix before my laptop froze for a second. Yeah, now it's fine. We want ax to be less than sum p. We want an to be less than sum q. And what is sum q? Sum q is equal to s minus ax minus an minus some p, right? That's s minus everything else. So we can check this condition too. And we want to minimize, again, what do we minimize? Well, the same thing. So it's some p plus ax minus, well, some q is this, so this is some q plus an. We just minimize this. So we can simplify it, but there is no need actually. Basically, we just try every possible sum of the first subset and just pick the one that satisfies all conditions. If we can't find the one that satisfies all conditions, we just output -1, -1. And if we can, we just minimize this difference, and that's how we get the answer. So that was quite thorough. Hello. I don't know. Has everyone profited from this explanation? Was it clear? Was it too clear? Was it too unclear? I don't know. I think it should be clear if you kind of understand the concept, but maybe it was even too thorough. Any feedback? How do I make sure that there are at least 3 elements in each set? I don't have to make sure that is the case, because if I have just 2 elements, I cannot have the longest side strictly smaller than the sum of all the other sides, because the larger side will always be at least the other side. If I have 2 sides, and if I have just 1 side, this is also incorrect because it's not less than 0, right? So I don't need to make sure that I have 3 sides, 3 elements in each side. It will be, if the conditions are satisfied, it will be automatically followed. I think it's a nice problem actually, in the sense that the solution is, well, it can be explained quite clearly, but it still has some ideas. Well, it's not hard problem. It's not a hard problem for like masters on code forces, but still, I guess that a lot of people should be able to comprehend it. So that's pretty cool. Yeah. So for today, I guess I have to solve problem F maybe, but I feel a bit tired for that. And I still don't know how to solve it. Let's maybe read the comments. Let's find any top sort and ORDU is position of unit and USB. Okay. No. No, but how do you check that? Oh. Okay, okay. I guess I understand. I guess this problem F is not actually hard. Maybe if I look at it this way, then it's pretty easy. Yeah, that looks clever. Okay. That was not intended to be an advertisement for Bonacqua, but anyway, it happened too. Can I give some advice? I guess practice. I don't know. It's a hard question. Just enjoy what you're doing. So, yeah, maybe I can even implement it quickly. Should I try to? Yeah, maybe. I will explain what I'm doing in a moment. Just Let me try to do it now quickly. And if it's correct, then I guess I will be able to explain. Okay, I guess I can do it this way, and then and also this. Could it be correct? No. 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 I shouldn't install it. It's not the first time it happens. And also it's so slow. Why did I install it? Oh, I guess I installed it for the quantum stuff. Really? Oh, well, no, it's weird. I don't even remember. Anyway. No, that's not good. Ah, okay. No. Okay. That's clever if it actually works. Too bad I didn't realize it. Hooray! No need for F5. It updates itself. Yeah. I have solved 6 problems today. Isn't it cool? Finally. It's been just 3 hours. But the contest was 80 minutes. But anyway. That's fine. Yeah. Oh. Yeah. Well, so yeah, I guess I can explain at least roughly what is given here. So the problem is we have a directed acyclic graph, and for each vertex v we want to decide whether like consider all possible topological sorting, like orderings of its vertices, and for each vertex v decide whether it's is at the same position in all top sorts. 14th place, good for me. Yeah, definitely. Well, I had a stupid bug. I could have been 6. 6 is better than 14th, but yeah, awful, disastrous performance, right? Why do you even watch this, right? Oh, I mean, you'd better watch someone who's at the first place. Why would watch anyone at 14th? I have no idea. Anyway, thanks for watching, actually. So, yeah, I want to decide whether the vertex has the same position in all top sorts. So, it's actually equivalent to deciding for each vertex v, decide whether for well for any vertex u, v is reachable from, well, we can reach u from v, or we can reach v from u. And here I mean a reach, like a whatever arrow b means that b is reachable from a. Yeah, so that's equivalent to this. So we just need to check whether we can reach any vertex or any other vertex can reach us. So the solution basically is find any top sort. Let's say we have top sort v1, v2, vn. It now means that for any edge vi to vj in the graph, we have I less than j. So that's just any, well, we call it top sort, I don't know, topological ordering, whatever, I guess, interchangeable. So for any edge, we have I less than j, so we have all edges going from left to right. So now we have to decide for each vertex v, decide whether for any u, let's just renumber the vertices accordingly. And now we want to decide whether for any vertex u more than v we can reach it, and also decide whether for any u less than v we can reach v from u, right? Because we can only go to the right, we need to decide if we can reach all vertices to the right, because we cannot be reachable from them, obviously, and vice versa. Okay? And now, well, I guess the solution could be, what's that camera link? Hi, Radevush. Should I say well done? Well, maybe third place. Are you happy about your result? Did you have just a small bug here? Anyway, so in this problem we had, yeah, so here's the thing. So we have a vertex V, and then we have some vertices to the left and some vertices to the right. Would work only with clockwise. Yeah, bad luck, I guess. F appeared at POI. Okay. So was it the case that, well, anyway, you weren't even the first to solve it. Did Amnik also solve it at POI? Or maybe later? I mean, I never did POI, but POI is Polish Olympiad in informatics, just for those who don't know. Yeah, but it seems that only, yeah, Mark could not solve it. So, I mean, it doesn't seem like it gave a lot of advantage. Anyway, so the thing is, we want to determine, so these are some vertices, and then we have some edges. Yeah, painting is hard, but anyway. So let's say we have some edges. Let's say we have some edges like this, okay? And then we also have some edges going over V, right? But in general, we don't really care about such edges. We want to find out whether we can reach vertex V from all vertices to the left. So we want to understand whether we can reach V from all these vertices. And here is one thing. Consider some vertex. Suppose that we don't have, let's say we don't have this edge going to V from the second vertex, but let's say that this edge goes somewhere farther to the right. So suppose that we have some vertex U such that let's say that this vertex has more than one edge going outside, but let's say that the first edge, the edge that goes as close on the sort order as possible, goes to a vertex after V. Okay, so suppose that from this vertex U we don't have any edges. We don't have any edges going to V or before. Let's say we don't have any edges to the yellow area, but we only have edges to the right. In this case, obviously we cannot reach V from U, right? If we cannot reach V from U, then the answer is no to our question, and then we are done. We don't need to do anything about vertex V. That's one thing. And actually, I claim that this condition is not only necessary, like it's necessary for the positive answer, but it's also, well, sufficient. If from every vertex before V we have an edge going to, like the closest edge that goes outside from this vertex doesn't go after V, but it goes somewhere before V, or straight into V, then we can reach vertex V from every vertex before V, because we can just use this closest edge. From each vertex, we just go and use this edge that goes as close as possible. And eventually we will get to vertex V. We cannot jump over it again, because we cannot, from each vertex, we never jump over V. So, and we always go to the right. So that's it. Oh, well, that's not the best explanation, but yeah, hopefully it can be understood. So basically, the thing is, for each vertex, I find the closest vertex. For each vertex U, I find the closest edge that goes to the right. Let's say it goes to vertex Z. And then it follows that for all, what colors I have? Purple. For all vertices between U and Z, for all these vertices, the answer is no. And no means that we cannot reach these vertices from vertex U. And then for every vertex, we just find this edge, the closest edge, and then we just mark on this segment that the answer is no. And then we do it for all vertices, and then we also go from right to left and do it in the reverse order. And basically that's it. We just determine the answer for all vertices. So let's see the Polish problem. Problem statement. So did you have the same solution? You copied your code from there, okay? Yeah, but so basically my code looks like this. Here I just find any top sort, and then for any vertex I find the closest, like the minimum position of an outgoing edge. Yeah, okay, copied your code from this Olympiad. I see. I mean, not from that link. That's fine. Did you have the same solution idea, or you don't remember? Maybe that's also possible. Anyway, I increased delta. I don't, if I don't do it like this, it will be on square, so I have to use some kind of prefix sums here to mark all vertices on the segment. POI is Polish Olympiad in Informatics. Actually, yeah, people say that they have a good collection of problems. You just came here and wasn't listening. If you want, you can quickly repeat this. No, that's fine, that's fine. You don't need to. You can just relax. I mean, I guess if you just look at this code, you can realize what this code is doing. I just find any topological sorting, and then for every vertex I find the closest outgoing edge to the right, and mark all vertices on this segment as like false. And then I go from right to left and do the same. And that's all. Try this problem. I mean, stop spamming, please. There is no need to send this link 10 times, okay? I don't have moderators, but I just want. So this problem is in, well, is it Serbian? Anyway, I guess I will not try it at least now. Maybe, okay. Never mind, never mind. So, how did you solve C, by the way? What was your solution to C? Given that you came. Yeah, we have some moderators online. That's cool. I guess no need to make any actions. K must be prime. That's right. What next? In X principle, prime smaller than K. Okay. just with backtracking. Okay, cool. That's what Ildar told me. I'm just not good enough to make such solutions. I mean, I just never realized that this will be fast enough. I even came up with such an approach, but I just didn't realize it will work quickly for some reason. But yeah, probably it was obvious. I don't know. Project Euler, Project Euler teaches that it always works. I mean, it depends on constraints, right? Or does it always work? I mean, my idea was that I can do it in a similar way as you find the sum of primes in integers in the range. Let's say you have some range from L to R, and you want to find the sum of all primes in that range. And yeah, I was trying to do something along the lines of that backtracking. But at Project Euler, you have infinite time, right? Even if it's slow. Anyway, teaches that it's a good idea to try backtracking. Okay, maybe I should do Project Euler and then realize it's a good idea, or I can just use what you wrote without doing Project Euler, right? I can just always remember now that when I have a problem about primes, I should use backtracking first, right? Okay, I'll try not to forget. Well, no, I just use QWERTY, not the work. The best math book after concrete mathematics? I haven't read any like real math books, so I can't tell. The problem you sent is harder than F in this round. Well, maybe. I mean, no problem. Uh, sorry, I guess I will not do it right now anyway, but perhaps... Was my guess correct, by the way? Is it Serbian? Yeah, Radesh. That's what I try. Go on primes from left to right and remember an n divided by the product of primes. Yeah, something like that. I had a solution with map, but it's just too bad. It's too slow. Something like that. It is Serbian. Okay, cool. My language detector worked. And last question, if I don't mind. I don't mind. Yeah, I guess I will wrap up soon. So, yeah. Have I specifically trained blind 10 fingerprint? No, I have not. I mean, I've done some typing. Well, not really. I mean, just doing a lot of typing practice is fine. I'm not even sure I use all 10 fingers, but I just don't... I mean, the general 10 finger, blind 10 fingerprint is... Well, there's some like... there's some strict structure, right? 10 blind fingerprints. No. Blind typing. 10 fingers. Yeah, I was looking for a picture like this. So here you have a keyboard, and then you kind of try to use... what about the big finger? Interesting. Anyway, something like this maybe. I mean, you try to divide all the keys into some sets and then try to use only this finger for this set of keys, but I never do that. I just type what... So I mean, my typing is not optimal, I guess. It's just whatever I feel correct, and that's I guess I have some kind of neural network inside myself that was trained. Yeah, basically I was just doing programming training, and that's all for typing. And for that's for typing in English, and for typing in Russian, I was just doing a lot of chatting. Also works. Uh, you have yeah okay. So okay, I will think about the problem. Not now. Last time you've observed that I am the fastest person ever to test program on samples, including copying. Copying is not typing, right? Blah blah. Okay. Mm, but maybe I should use some plugin, right? Because I know that, like, have you seen, like lately? I think that there was some kind of yeah, it was a block. Yeah, like this one. Yeah, CF booster. Maybe we can actually. I don't know. Maybe if I use this, it will be even faster, right? I still spent some time copying. Yeah, I mean, I'm not. Yeah, you observed it here on stream. That's true. That's true. Someday I will have a chance to observe how others do it, and I just mean, streaming is some kind of showing your cards, somewhat, right? For the real competitions, I mean, I'm kind of showing how I do it, and everyone who watches this can figure out something that they can do faster, right? So I guess that it can be useful for many people watching this, but if I don't watch streams like this, if no one else does streams like this, I'm in a weak position. I cannot teach, I cannot learn from from what others do. So maybe we should have more streams like this. Anyway. Mm, hmm. Okay, I guess I could do some typing tests later, next time. Yeah, be sure to come here next time. So the next stream is planned to be in 6 days. So today is, yeah, it's already 23rd, but it was on 22nd. So now the next day is 28th. So it's in 6 days. In fact, in 6 days I will be at Petrozavodsk training camp. And yeah, I mean, I'm not sure what will be the best place for streaming, but I assume that I can get some other people around to get a more fun stream, maybe. So be sure, if you will be at Petrozavodsk, be sure to join. Maybe we can figure out something. I don't have a Timus page, I guess. Maybe I never solved a lot of problems at Timus. So, I mean, I don't even remember my credentials or something. I guess you can look it up just like I can do it. My complexity in problem E. Yeah, by the way, Radevush, why are you not coming to Petrozavodsk? I think you're not. Why not? My complexity in E was n square times L. L is the maximum integer, so it's 40 times 40 times 100. 1600 100. University, okay, yeah, makes sense. Maybe it's just about the schedule, because the way it is, like the schedule is, like of the camp is held in the end of January and beginning of February, and that's usually the like the week off, kind of. It's the week between the exams and studying, something like that. What was your complexity in problem E, by the way, given that you asked? Let's say second year of university. But you already participated twice in the ICPC and your second year. Makes sense, makes sense. I guess I know some other people who do like that. I'm not gonna ask about the reasons. Anyway. Oh. Yeah, yeah. I was kind of going to do it in using meet in the middle when I saw 40, and after that I saw 100. It could, yeah. I mean, this problem should be solvable in 4 longer sticks. Yes. If n is at most 40, I guess we can solve it in using meet in the middle. So it will be 2 to the power of n divided by 2, n over 2. So 2 to the power of 20 is 1 million. That's not much. We can do it. But it's complicated. It's quite tricky, I guess. But probably not so much. How many problems I solved in my lifetime? Well, it should be more than, well, that's a hard question. Quite a lot, quite a lot. More than 10,000, I think. But it's hard to estimate. Anyway, I guess I'll wrap it up now. So thank you for watching. Hope you enjoyed it. Be sure to come in a bit less than 6 days. Today was +6, correct? Be sure to come in 6 days, and be sure to follow if you're not following yet. And sorry for bad performance, I guess. I'll try to perform better. Maybe it's about streaming. Maybe just streaming makes me worse. We'll figure it out later. Or maybe I'm just becoming older. Anyway, thank you. So, see you. And yeah, one more note, I guess, is that if I decide to make new streams, I guess I will announce it Code Forces anyway. Yeah, whatever. So I guess the schedule must be at the Twitch page. And yeah, whatever. Follow whatever is comfortable for you. Okay, so thank you. Bye bye.